Alright, welcome to my first session of chemistry using my new Waco pad and drawing on paintbrush. So this will be chemistry and paint. If we're locked down for the entirety of the coronavirus, I imagine that I will become more skilled at using this pad, but you'll have to forgive my lack of dexterity with it. It clearly is a skill because you've got to look at the screen. You can't look at the tablet while you're writing on it. And I've never done anything like this before. So we got to select the pen, and we're going to go drawing today. We're going to have some fun with ethanoic acid. We're going to have some fun with ethyl ethanoate. So ethyl ethanoate is, of course, a ester. It's otherwise known as nail polish remover. It has that really unique scent that you get at Nails Paradise. I mean, some people find it yuck, and I love it. I love the smell of nail polish remover. I don't know why. It's like when you open a brand new pool toy and it's got that plastic vinyl smell. I love that too. I think you can't be a good chemist, you know, because I did a year in the lab doing some research. You can't be a good chemist unless you like the smell of things. It's all part of it. This is ethyl ethanoate. We name the alcohol side first, of course, and then we name the carboxylic acid side. It's a condensation reaction, so when it's formed, it drops off of water. I think in the past I've indicated that the hydroxyl group comes off the alcohol and the acidic proton comes off the acid, and as a result it kicks off of water. But from what I can see, it's actually far more complicated than that. So if you watch the Fischer esterification video, watch vid, not required, but if you want an A+ in your practical report, it's something to consider. It was great material for the introductions for my very high-level practical reports last year, because it's actually considered university-level chemistry. It contains a lot of fairly intricate steps. So esterification is not a process that just happens by getting one thing and jamming it into the other and kicking out of water and there you go. It's got to go through several intermediate steps. So if you watch the Khan Academy video, which I'll put up online, you'll see what I mean. I mean, the process goes for 17 minutes when they're talking about it. Now, you don't just have to stay as an ester. An ester is a very stable compound. It's not like you see a whole bottle of nail polish remover turning back into vinegar and alcohol. If it did, it wouldn't sell very well. But you can do the reverse of a condensation reaction, which is a hydrolysis reaction, and you can do it in two ways. You can do it in the presence of a strong acid and a buttload of heat and refluxing in time, and you can do it in the presence of a base. So I'm ignoring whatever's been stuck here. It could be hydrochloric acid, this could be sodium hydroxide. Whatever it is, it must be a strong acid and it must be a strong base. Now in the presence of an acid, you're going to get your alcohol. That's no problem. Alcohol's got no problems hanging around in an acid. It's quite a stable substance, and of course it's very polar. And then the resulting ethanoic acid will also be present. So you got your double bond O and bond OH. The key thing here is that when you're dealing with a base, it's a totally different environment. Yeah, you'll get your alcohol. Again, alcohol's got no real issues hanging around in a basic environment. It's quite okay with that. But your acid's going to be quite different. There ain't no acid that's going to be sitting there with this H+ attached to an O- and then to the whole thing. This acidic proton that's sitting off the side here, this one right here, that's going to disappear. It's going to get mopped up by all this excess hydroxide that's hanging around and turn into water. So it'll immediately get neutralized. So in basic environment, you're not going to see that. In a basic environment, you're going to see the carboxylate ions. So you'll be required to draw the products in acidic and basic environments. I can tell you now, I'll put it in your test. All I got to do is change the ester. So, you know, what comes off the side chain is going to be different. So you're going to get left with an... I'm not doing too bad here. This is all right. I don't mind it. You don't know this, but this is like my third crack at making the video. I've made some terrible stuff, and I was very unhappy with it. I've got this lean where everything seems to go up and to the left, so I'm not sure. I guess I'll learn how to fix that over time. Key lessons to learn. In an acidic environment, when you hydrolyze an ester. You need to have a water, like water must be present so it can get jammed back into the equation because it got taken away. So it's the opposite of condensation. And then acidic environment, you're going to get your carboxylate ion. However, in a basic environment, make sure that you don't have that H there. Just draw the carboxylate ion, making sure you got the O minus there, recognizing the fact that any proton's going to be soaked up by all this hydroxide hanging around and turn into water. Right, the end. That's it for esters. Take care of yourselves this holidays, please. I don't want to see anyone getting the coronavirus and all that sort of thing. Look after yourselves, look after your families, and stay in contact. If it gets to the point where we're not coming back for term 2, where it's just like on and on and on and on and on while we wait for all of this stuff to end, then yeah, we're going to have to remain flexible. All you can know is that I am here. Oh, I need a H. Here for you, and it might not be at the stated time in the timetable. It might not be straight away. I've got a 7-year-old and a 5-year-old at home, and if we're keeping them home so they don't get COVID, just like you're staying home so you don't get COVID, then I've got to deal with them too. We all got to remain flexible here, but rest assured that, while my job is to be your chemistry teacher, and while I'm breathing, even if I'm in hospital struck down with COVID, I would still be doing my best to be delivering you materials.